This is our new doctor of agronomy, Svetlana Vujić. She and Leonardo are actually our PhD students. And
We were.
certain way results of this project. So, Svetlana, please.
So, good afternoon to everyone. My name is Svetlana Vujić, and I will present you some part of my thesis. And my defense was on beginning of March this year, so it's still fresh, still warm. And the title is The Establishment and Production Quality Characteristics of Sainfoin in Intercropping. So there's some new words. So at the beginning, I will just introduce you more with the sainfoin, because this species is not so common in agricultural practice. So the origin of sainfoin, or Onobrechis vicifolia, is south part of central. This part. It's mainly from Turkey and Iran, and from that part she moved in Europe and worldwide. So, but today the largest area of sainfoin are in Turkey, over 90,000 hectares. In some parts of East Europe, then Italy, Spain, Kazakhstan, and Iran. But there is no statistical data about the areas under this crop. So the sainfoin is one perennial forage legume. She lasts about 5 to 6 years, up to 8 years, depends on the conditions. And somehow it can be considered as a potential substitute for alfalfa, which is the main forage crop. But it's more familiar as a honey plant because it's rich in nectar and pollen and is useful for honey production. That name, sainfoin, comes from the French. This sainfoin, I'm not sure that I pronounce it well. So it means healthy or holy hay, depends on the translation. Why is that? Well, this species or forage of this species is very rich in crude protein, so it averagely has about 19%, but it's going to about 23%. But furthermore, the most important thing is that contains these tannins, which increases the protein absorption in ruminants, does not cause bloat like alfalfa do, and can have effect on decrease of gastrointestinal nematodes. So it has many benefits on the animals. But besides that, when we are talking about the growing of sainfoin, there are some, let's say, problems. So this sentence maybe is the best way to describe that. So this sainfoin is something like an agriculture paradox. From the point of view of animal nutrition, it seems to be the most desirable plant, but from an agronomic point of view, it's an undesirable plant because it doesn't grow very well. So why is that? So not only in Serbia, I will say in the whole world, there is no adequate genotypes which are persistent or tolerant to some diseases, which are the main cause of destroying this crop. And another thing is that the growing technology of this crop is still not sufficiently developed. But when we are talking about growing of sainfoin in temperate region where we are now, there are 2 times of sowing. So we can sow that in spring and early autumn time. But the most common is spring sowing, and I will focus only on that part. And in that term, it is the good conditions when we are talking about the temperature, the soil moisture, and those conditions are well for the establishment. But in that year, we are achieving low yield. But another problem is our weeds, because those conditions are well for the weeds, like is for the sainfoin. So we try to search some way to establish this perennial legume and to overpass this problem with the spring sowing. So we try to use intercropping. This is another new word. So intercropping is simultaneous growing or two or more crops at the same field without necessarily sowing and harvesting them together. So it's important that those crops pass through some part of growing period together, and to have the influence of each other. And it can be considered that is a practical application of ecological principles based on biodiversity and plant interactions. So as you can see in this, like this, and in this system, in intercropping system, there are numerous interactions in above ground and below ground part, and it's considered as the use of available resources is much more efficient than in soil crops. I mean, use of water, solar radiation, nutrients, and so on. So, but we are talking about above ground interactions. We mostly mean on crop characteristics. I mean, leaves position, the intensity of photosynthesis, light penetration in deeper parts of the crop. And when we are talking about below ground interactions, then we are speaking about root characteristics mainly. I mean, the depth, the density of the root, the possibility of nitrogen fixation, the possibility of using the water and the nutrients is in some forms that are not so available. Generally, the success of intercropping is mainly depends on selected species or cultivars and the crop densities, and that those two factors mainly affects the yield and the quality of the forage. And this intercropping practice is not something new in establishing perennial legumes, and there is something like a traditional way of establishing with perennial legumes with grasses and cereals, something like this, that we have that row intercropping, one row perennial, one row of cereals. But we try to find some alternative way, something new. So we try to use this sainfoin with field pea, or to use field pea as a companion crop, based on some of our previous research. And of course, we should analyze how those two ways affect yield, quality, and of course weed control while we are doing all of these things. If we compare grasses, cereals versus field pea, we can see that with the first one we can achieve high yield, efficiently to reduce weeds. But on the other hand, the strong impact of cereals affects also the perennial legume and their regrowth in subsequent cuts. And usually the digestibility or the quality of that forage is lower. So, but when we are comparing that with the field pea as a companion crop, we can see that we can achieve the high yield, high quality feed with a high content of proteins. The both are the crops that can fix nitrogen, and we can reduce weeds, and those crops can have better effect on regrowth of the perennial legume. So, having in mind all that I said, we established some objectives. So, our objective was to determine the suitability of field pea as companion crop in intercropping with sainfoin, then to determine the most suitable field pea genotype and number of pea plants, how field pea affects yield, quality, some physiological, morphological properties of sainfoin in intercropping, and to analyze what is the impact of two legume intercropping on microbiological activity and nitrogen content in the soil. And we followed this crop more, and to analyze the impact of companion crop on the sainfoin yield in the full harvest year, which is considered as a second year of its life. So, we set up the experiment at the experimental field of the Institute of Field and Vegetable Crops, calling Rimski Šančevi near Novi Sad, and that experiment lasts from 2010 till 2014. It was established as a 2-factorial field trial and included sainfoin, this cultivar, and 2 factors. Factor A was the field pea cultivar. We used 2 P cultivars. One was with aphylla leaf type, and another was with normal leaf type with reduced leaflets. Another factor was field P plants per square meter. So we used three densities. We had 30, 60, and 90 plants per square meter. In order to compare those results, we established two control variants. So we had control one, it was the pure stand of sainfoin, and another was the sainfoin in combination with oat, as I mentioned, that kind of traditional way. As you can see from this table, we had 4 years of establishing the crop, and we followed that crop, each crop in another year in the first cut. But based on this, on these results in this table, you can see that the number of cuts significantly varied between the years, which is mostly affected by the weather conditions that we had in our experiment. I will talk about it a little bit later. So those are some pictures from the experiment, the establishing, the beginning of growth, and in the time of cutting. So we evaluated many parameters, and we divided them in above ground and below ground side. So in above ground parameters, we analyzed, of course, dry matter yield of the first cut, as well as the total annual yield, first cut in the second year of life, then with proportion, some physiological parameters, and some quality parameters. On the other hand, we analyzed below ground parameters such as microbiological activity of both sainfoin and field P, and as well as nitrogen content in 3 terms. 3 times we took the samples into soil layers from 0 to 30 and 30 to 60 centimeters. More pictures. Based on this data, you can see that the soil properties were adequate to growing all these crops that we selected. But that wasn't the case when we are talking about the weather conditions. As Georgia mentioned in the other chart that we had that 2012, and according to the hydrometeorological service of the Serbia, till that time it was the second driest year. I mean, about 50 years long period, and we had not only the very temperatures which were above the average this red line, and the green is 2012, but we also had very, very low amount of precipitation. And even though in some months we had enough precipitation, the distribution was very unfavorable. And the results, I just selected some of them. And as you can see from this first figure, in the first cut, those are the average from the old 4 years. The highest yield of the first cut was obtained in the combination of sainfoin and oat due to high proportion of oat in the mixture. And the lowest was in the sainfoin pure stand, and that was the similar in the total annual yield. But the more effect have been shown in the second year, in the first cut of the full harvest year, when we can see that those control variants had significantly lower yield of the forage, diameter yield, than in combinations with field P cultivars. Moreover, this is the graphic that shows the proportion of sainfoin, these pink ones. Those are the companion crops, and those are wheats. So you can see that in pure stand is the highest proportion of wheats, and the lowest in the combination with oat. But however, this combination highly affects the sainfoin comparing to the field P as a companion crop. Concerning the leaf area index as one of the physiological parameters, you can see that the leaf area index was the lowest in combination with oat, because with that aggressive impact of that, species on sainfoin growth and development, comparing with the numbers that we achieved in combinations with our cultivars of field P. That was the case also with the pigment content. I mean, total chlorophyll and carotenoids content in sainfoin in the first cut. So we can see that the lowest was in the sainfoin pure stand, and in all mixtures we had the higher content of those pigments, and probably as a shadowing the plants and the effect of that companion crop of the photosynthesis and all other aspects of developing the leaves of the sainfoin. I'm just showing you this, that we calculated water use efficiency of sainfoin. In this case, it was the ratio between intensity of photosynthesis and intensity of transpiration. And we analyzed that the best results about, between that production and the use of water was in combination with the 60 pea plants with both cultivars. So I selected only these nitrogen-fixing bacteria to show you the results. So we followed the number of rhizobium nodules in both field P and sainfoin root. So you can see that in combination with this cultivar with normal leaves, we had a higher number of nodules on the root of both crops. And when we are talking about the number of azotobacter as a free-living nitrogen fixation bacteria, we are having also higher number of those bacteria in rhizosphere of the both field P and sainfoin. Soil mineral nitrogen we followed in 3 terms. So you can see in June 2013, in November before the winter time, and after the first cut in 2014. And I just wanted to show you that this yellow one is the nitrogen content in combination sainfoin and oat. So you can see that even though we had a combination of 2 legumes, they did not negatively affect of the nitrogen content in the soil. And one of the reasons why we grew these two plants is that to increase the protein content in the forage, and we achieved that. So as you can see, the lowest was in the combination with oat with 12.4, and with high this parameter, it shows you the digestibility, so the use of the total forage that animals enter in the rumen. And we obtained more than 20% of crude protein in the combination of sainfoin and field P. So the conclusions are that the weather conditions had significant impact on yield performance and yield components, that the dry material yield in the first cut was higher intercropping of sainfoin and this cultivar with aphylla leaf type, and without differences between 60 and 90 pea plants, which is important from the economical point of view to decide what to apply, and that in full harvest year, that companion crops did not affect its yield, so sainfoin developed like the same normally without any negative effect, and the highest wheat proportion was in the pure sainfoin stand, and in average, the sainfoin, this cultivar had higher competitive ability in intercropping mixture. So we can make some 2 general conclusions, that the obtained results show that sainfoin can be successfully established with field P in the intercropping, and that intercropping can be considered as a reliable and ecological practice for sainfoin establishment, which provides the possibility for increasing production of these species. So, thank you.